Hi, I am José Valim, and today I'm here to talk about a new computational notebook platform called Livebook. So the whole presentation is going to be given in Livebook, but before we talk about Livebook features, I want to talk a little bit about Elixir, which is the programming language that powers Livebook. So Elixir is a functional and dynamic programming language that runs on the Erlang virtual machine. So as a dynamic language, I can create a list with a string, an integer, and an atom. And Elixir data structures are immutable by default. So for example, if I remove an element from the list itself did not change. There are many features in Elixir, pattern matching, meta-programming, worth talking about, but today I want to focus on concurrency and distribution. In the Erlang virtual machine, all code runs inside lightweight threads called processes. We can literally create millions of them. So if I execute this code that is literally spawning a million processes, we can see that it ran in 1.7 seconds. And all those processes, they are all isolated. We start them, they are all isolated, and they are all running at the same time. And if we want them to coordinate, to work together, we do that by sending messages. So I have this piece of code here where I spawn a child process, and it's going to wait for a ping message and send a pong back. And then the parent's going to send a ping message to the child and wait for the response. So if I execute this code, we can see that it worked. But the cool thing is that with Livebook, without Livebook, it may be a little bit hard to understand how this code is working. But with Livebook, we can ask it to render the trace of how the processes they are calling and interacting with each other. So I can see here how a process spawns the other, it sends a ping and receives a pong. And what is neat about this is that it's going to work for more complex use cases as well. So for example, in Elixir, we have this task module, which is really useful when you want to do multiple things at once. Doesn't matter if it's CPU work, IO work, you can just throw whatever you want at it. So for example, imagine that we want to render some images and download a website at the same time. So we can use a task to do that. So I'm simulating some workload here by sleeping. And then if we instrument this cell, if we execute this cell and instrument it, we are going to see that we can see this trace as well. And every time we execute, we get a slightly different trace, right? Exactly because we are sleeping by a random amount of time. But this is going to allow us to build this intuition of how our tools work, right? How the language works. And not only that, because everything works as processes and they communicate through messages, those messages can actually be distributed across nodes. So for example, let's try to execute something in the distributed module. This notebook does not have a distributed module defined in it, okay? But what if this module was defined on another notebook? So here I have another notebook that defines such module, and each notebook is a separate Erlang VM, okay? What this means is that if I get the node of this notebook here, okay, so here in the original notebook, let's ask it to render some input, so one for the node name. And if I get the cookie of this notebook too, it means that I can put those things here and do an RPC call to that node and execute whatever is in the distributed module. You can see that it works. We got the response back. So we can see how distribution works here. There's a lot to talk about, but this is an enough introduction for us to understand how Livebook works. So let's talk about Livebook. So one of the features in Livebook is that it has truly reproducible workflows. But what makes a notebook hard to reproduce? Right? We have two sources. One is the out-of-order execution, and the second one is the global mutable state. So for example, if you take a Jupyter notebook, we have the state, we have cells, and we can run those cells in any order. And what they do is that they kind of get the state and write to the state, and they can do that in any order. And that's going to be that's going to be a cause for making the notebooks hard to reproduce. We have seen attempts to linearize this execution. So for example, if cell A defines a variable x, and cell B depends on this variable, before we execute cell B, we are going to change cell A and we can track how they are stale. So these improve things, but ultimately it addresses the out-of-order execution, but we still have global mutable state. So in these notebooks, for example, if we have this code x equals 1 and another cell tries to increment it, if we execute this cell multiple times in other notebooks, the value of X would keep on incrementing. But that's not what happens in Livebook. The Livebook execution model is fully sequential and there is no global mutable state. You can think of each cell as a function where it receives an input and returns the output, and that output is going to be the input of the next cell. And with this, we can track inputs and outputs with a little bit of static analysis. We know like, hey, if cell B changed and cell C does not depend on the outputs of cell B, we don't need to execute cell C again, right? And we can track when cells go stale as well. So for example, if I come here, change the value of X, we can see that it's saying now that, hey, this other cell became stale, right? So that's how Livebook works. It's truly reproducible because we got rid of the true sources, we got rid of the out-of-order execution, and we got rid of the global mutable state. However, you can say, hey, isn't a single, even with caching, isn't a single sequential execution like too limiting? What if I want to run some experiments, right? So this brings to another feature that we have in Livebook, which we call branched sections. At the end of every section, we can start a new section in the main execution flow, but I can also create a branch from that section, which is basically going to get the outputs from the previous section and branch from there. And this brings two features. So one is the ability to experiment, right? And we can see that we are inside a branched section now. So it gives us the ability to experiment, but each branched section is running on a separate process, which brings concurrent execution. So for example, in this branched section here, let's execute this infinite loop that every second prints how much memory the notebook is using. And as we are going to see, this is going to keep on running and is not going to affect the main execution flow of our notebook. So another feature in Livebook is multiplayer runtimes. So let's talk a little bit about the architecture, right? So the Livebook is a web application, which we are accessing here, and then we have the session representing the notebook. And your code, the code that we write here in the notebook, it's running on another Erlang virtual machine, right? So your process is running in this other Erlang virtual machine, and we communicate between those things using the Erlang distribution that we used early on, okay? So this brings a separation of concern where your code that is running the notebook actually knows very little about Livebook. It knows nothing actually. And if you want to interact, have those things work together, there is a theme library called Kino that plays in the midfield here, okay? And what is cool about Kino is that it brings us the interesting features like rendering the sequential trace between the processes, right? But the other thing that it does is that it allows us to create our own outputs. We can create any output that we want to be rendered inside the Livebook. And the outputs, they have two shapes. They are either static or live. And I want to show an example of a live output right here. Let's build a counter. So in about 50 lines of code, we can build a counter with some Elixir code that we can see here. And this code is going to receive events and send events. And then we write a little bit of HTML and a little bit of JavaScript to send and receive those events from the client. And now if I execute the cell, what we are going to see here is exactly the counter, right? We render the counter, we render a button, and we can bump this counter. But what is really neat here is that if I have this notebook open on another tab, as I have here, we can see other nice features, which is that Livebook is actually collaborative. So as I'm selecting something here in the code, we can see the selection reflected here. So everything I do in one notebook is going to reflect on the other. But not only that, the outputs themselves, they're also like real time, they're also collaborative, they are multiplayer, right? And what this means is that you can use Livebook to create real-time collaborative experiences. We even have an example on how to build a Pong game using HTML and SVG and have it play from two different notebooks using Livebook. And the reason why this works is because if we take a deeper look into architecture, what we have is that we have this. We have Livebook with the session, and then we have different clients that connect to Livebook via WebSockets, which allows like the events to come and go, right? And then the Livebook is connecting to our code, the process, the Erlang process running our code, and each output is their own Erlang process as well, which again means that they can all be running at the same time, receiving events and returning to events. With this in mind, we can now talk about perhaps the most important feature in Livebook, which is smart cells. So we are talking a lot about Erlang processes, and we also have, the Erlang VM provides a lot of observability around them. So for example, I can actually list all processes and get information about how much memory they're using, how much work they have done as the reductions counter because they are preemptive. And we get this list. But wouldn't it be nice if we could actually plot a chart with it? It would be really cool, right? So we could learn how to use like a charting library. But in Livebook, inspired by the work on Mage by Mary Beth Carey and co., we have this feature called the Smart Cell. So I can come here and say, hey, I actually want to plot a chart. And it's going to say, hey, to plot a chart, you need the Kinovigalite package. So we are going to ask it to install the Kinovigalite package. And what is really cool about this is that we can see that Livebook also knows about dependencies and package management, which again is important for the reproducibility story. And then after it installs the package and re-renders the notebook again, execute everything again, we can see the smart cell here, right? And it already detected that we have this process data and that we can plot this data. So we can say, hey, in the x-axis, let's keep the memory. In the y-axis, let's plot the amount of reductions. And let's print a different color for each status, if the process is running, waiting, or so on. So by choosing these, now we can execute the smart cell, right? And it's going to plot the graph for us, so we can do further adjustments. Let's increase the width. And we can see that, the dots, they're still all together here. So maybe let's try using the log scale here. And that's better. Maybe we should use the log scale for memory as well. So you can see here that with the smart cell, we can very quickly build this chart. And I know that for this audience, there is nothing new here. But what is really interesting about smart cells is that they are not special at all. They cannot actually interfere with the code in the notebook. They do not even change the execution model that we saw in the previous sections. All a smart cell can do is to say, hey, run this code. And the code that it runs, we can see it at any time. We can go and introspect it, which means that smart cells, they are great as learning tools, because if I want to plot something and I have no idea how to do that, I can use the smart cell and have the UI write the code for me, right? And then I can go look at the code and build from it. And if I'm an experienced developer, I can actually ask to convert the smart cell into code. And now I can go and further extend it, modify it, do whatever I want, right? So as an advanced developer, I'm not stuck in whatever features the UI gives to me. So, and this is just an example of our smart cell. We can create a smart cell to perhaps talk to the database, to plot some maps, execute SQL queries. And what is really cool about smart cells is that they also run as part of our code. They are not a Livebook feature. They're actually defined in our code as our own code, as the live outputs, and they run in their own processes, which means we can have several smart cells all running at the same time, receiving their own events, returning their own events, right? And because it runs on our code, we can install them as a package. So if you want to build a smart cell and you want to share with somebody, you publish as a package to the Elixir package manager, right? Or if you want to use a smart cell that somebody built, you just have to install a package which the notebook supports. So we're really excited about this because we want Livebook to be this tool where you can really extend the types of notebooks that you can write. You're not limited we're not limited on whatever we think about and whatever we support. You can extend it and you can really use it to build those interactive experiences thanks to the Erlang virtual machine. So that's all I had to share for today. I just have two brief topics that I want to talk about. So some quick mentions, the notebook source is a subset of Markdown, so it's actually readable. You can read it, you can version control it, you can code review it, and you can access the notebook for this presentation on my GitHub. I didn't use the editor a lot for time purposes, but the editor supports code completion, documentation, and much more. And if you decide to give Livebook a try, there is a learning section with several example notebooks. And we of course have a long roadmap ahead of us, but they are, so you can check out our issues tracker, but there are 3 things which may be of interest to this audience. So one is that we have been tackling the pain points listed in what is wrong with computational notebooks, and we have 2 remaining out of the 9. We are also working on smart cells for data and machine learning, and there are a lot of exciting ideas in this area. And many of those ideas come from like previous presentations at this live workshop. And we also want to explore usable live programming ideas, example-based live programming ideas, and so on. We actually started working on this, but I do not have time to cover them, but I wrote an addendum for those who may be interested. So that's it. The Livebook team is very eager to receive feedback, so feel free to join to those discussions, or feel free to reach out to me. I am José Valim on Gmail and pretty much every social network out there. So if you want to chat, it will be very welcome and appreciated. Thank you.